you guys hear me okay? Okay. So, yeah, thanks for that good introduction. Let me just add on to that introduction by, saying little bit about my role, the role that I play at Credence. I lead the data engineering practice. We are about 750 people. We are a 10-year-old company. We focus primarily on modernizing some of the data and analytics platforms. That's core of what we do. Plus, we're an analytics services and solutions company. So a lot of what we do is to make sure the right end of the analytics is really, the promise of analytics is really fulfilled. So that's the big focus area for us. With that said, done 20 years of consulting in data and analytics. So I've seen ETL, modernize in the course of last 2 decades from being very database native programs to ETL tools, ELT tools, packaged analytics, and now, of course, the modern frameworks that are executed on distributed compute either on-prem or on cloud. Right? But in the last few years, what I come to notice is the T in the ETL or ELT is kind of losing the sheen. Right? There's for many reasons. Right? So I'll get to the reasons why the T is actually losing the sheen in the modern world. But there's also a need for a lot more agility in getting data ready for consumption. So that's also pushing how we do extract and load processes as well, right? So there's this whole cloud zero ETL. There are native offerings that are coming up. Both Amazon and Google have come up with offerings that promise to actually do away with extract and load, right? So essentially, you can do away with extract, transform, load, and conduct analytics right at the source itself, or otherwise just at one common query layer where you are able to, select data from different platforms and be able to run analytics, right? So that could be data prep, that could be transforming data or provisioning data sets to some of the downstream applications, etc. But how real is that, and how far is that away? Because again, as I said, T has kind of lost its sheen in the last few years. So is E and L are also heading the same direction, right? So if cloud zero ETL has to become real at some point, then there is no extract and load anymore, right? So ETL existed for about 50 years now. So again, there's not really a clear history of when ETL was started, but ab initio started in 1973 or 1974. So going by that, it's about 50 years that ETL existed, but we've, I think, reached a point where it seems that is the whole term ETL itself is threatened in a way, right? So I wanted to talk a little bit about how we got here in terms of why T lost the sheen, plus do we think E and L are actually heading in the same direction, right? And then also tell you a little bit about how far away from the whole zero ETL, zero ETL as a concept, right? Yeah, so let me actually take a step back before I get into the T losing the sheen, right? What does a data engineer do? I think majority of you in this room have teams that are actually performing day to day a lot of these activities, right? So if you look at a data engineer right from discovering data sets and all the way to provisioning those data sets for either descriptive analytics or otherwise data science or otherwise a machine or an app or otherwise a third party, there are a series of things that a data engineer does, right? But in terms of the degree of complexity and where a data engineer really spends their time in all of these dozen different activities, that can change depending on the variables that you have in each landscape. But in some fashion or the other, every data engineer is focused on majority of these tasks on a day-to-day basis, right? Right from identifying the right source and extracting that information, building right data models, transforming some of those data sets, and then making sure those data sets are actually ready for consumption, right? When I say ready for consumption, you have, right, they are cataloged right, there is enough data quality rules that are put in place so that you have enough confidence about the data, and finally, you use some of the modern DevOps CI/CD practices to deploy these pipelines and all of that, right? So because you don't want to be doing very traditional way where you would actually develop something and then the same developer takes something manually to the next environment and so on and so forth, right? So a lot of these actually is part of everybody's routine today, right? But the degree of some of this, right? So in terms of does a data engineer really do data modeling, or otherwise we have a dedicated data modeler is nuanced, right? So because again, depending on the complexity, we may actually have someone else do it. But at least from the familiarity, expertise, and experience, you would actually look for all of this in a data engineer today, right? But I'm going to touch a little more on the extract and transform, because obviously I wanted to get to why T is losing the sheen, so I don't want to really focus on all the other aspects of data engineering's routine. But I want to quickly focus on what enrich and transform, what a data engineer actually does today, right? So a bunch of things, right? So combining data from different data sources, cleanse the data, enrich the data, right? Combining the data from different places. Then, validating the data. Sometimes you actually have to split the data. Sometimes you have to normalize the data, standardize the data. So there are a bunch of things that a data engineer does today to make sure that data is ready for consumption, right? So that data, when I say ready for consumption again, it could be a report, it could be an algorithm, it could be a machine, it could be an app, it could be, a web application, mobile app, whatever it is, right? So, but a lot of things that a data engineer does today require tools that will enable a data engineer to do this really well, right? So otherwise, you'll have to write a ton of programming to actually accomplish some of this, right? But a lot of this is going away. That's my core point. That's what I actually started, right? So the premise is actually a lot of what we have done over the years is going away for different reasons. But before I actually get to why the T's, all of these 10 different things that I talked about in enrich and transform are going away, wanted to briefly touch upon how the modern platforms have evolved over the last 20 years, right? So that's the world that I've seen. Data warehouses, this whole single source of truth in every data warehouse. When we started to design, one of the core premises that we needed to address was actually make sure that you have one single source of truth. So that's essentially bringing data from different data sources. It could be ERP, CRM, it could be service systems, etc., and bringing that all at one place and making sure that you are able to build your KPIs on top of that, right? So that existed for many years. On data warehouses, you also got packaged analytics. Oracle, Teradata, IBM all had come up with different data models that were packaged, and it also came with packaged applications as well, right? Then came data lakes. So there was that period of time when Hadoop became, go-to platform. All of us thought Hadoop is the future, and of course, a lot of the underlying architectures are still, powering some of the modern distributed computing platforms. So data lakes actually, whether it is on-prem Hadoop or otherwise in cloud, so data lakes became, very popular thing, right? So the way to look at any architecture for a period of time was to make sure that you have a lake. But of course, it came with some constraints, right? So it had its own challenges when it comes to consuming data and also, some of the asset controls, etc. So that's where the data fabric and data lakehouse are actually trying to address some of those constraints, right? So what fabric and lakehouse are trying to do is make sure, the challenges that you have in lake and the advantages that we have in warehouse are actually combined in these, these architectures, right? So that's how the data platforms have evolved over the last 20 years. So today, if you look at any modern architecture, you'll either find a fabric of sorts where you have a lake and you've got a warehouse and you've got some domain-specific data marts that are powering reports, analytics apps, etc. And you have data lakehouse, which is a lake plus data warehouse, right? So the lake is sitting in some sort of a object store, and you've got a data warehouse that is sitting on an MPP or a relational database, right? So now, while you look at the activities for a data engineer, it remained consistent, right? So I talked about a dozen activities that a data engineer does. In any of these platforms, any platform that is following one of these architectures or a hybrid of sorts where it is following one or more of these, actually still use these 20 different tasks. The data engineer still does all of these tasks. That has not changed, right? So what has remained over the last 20 years is the activities that a data engineer does, right? But in terms of the time it takes and the ease at which somebody can do these things has changed, but it should remain consistent in terms of what a data engineer does, but whereas the platforms have really evolved over the last 20 years. Now, I wanted to quickly touch upon, also some of these very simplified view of, again, obviously all data engineers really want to see architectures that are complex. The boxes and arrows are something that we are all used to. So if you see anything that I think the previous session, they touched upon one of the aspects. Anything that a data engineer does today is actually the consumer in mind, right? So you have, you know exactly who is going to consume this data. You want to make sure you're building your data models, your pipelines, and all of that, with the consumer in mind, right? So if you simply, again, you can get a lot more complex on the consumers, you can get a lot more complex on the producers, you can also get a lot more consumer, a lot more complex in the center of it, which is, the data wrangling, data transformations and all of that, right, where data moves and all that. But at very, very high level, right, so on the consumers, you have analytics and BI apps, and you've got data science applications, and you've got machine learning apps, right? And on the producer side of things, there are a bunch of source systems that are structured, semi-structured, and unstructured, right? And if you see in between, this is classic of, all that you saw in the previous slide, right? So you've got warehouse, you've got lake, you've got, streaming data sets, and, typically there is always, it's never a linear flow of data, right? So there are all of these architectures in any enterprise scale when you build, the data is moving from, let's say, streaming engine to lake, and then lake to warehouse, then marts, and then powering some app, right? So it's not, none of this is actually left to right linearly flowing. This is always, there is, complexity when it comes to how we want to really combine these data sets and use this data for, the consumer side of things, right? So now, if you see, this has changed significantly over the last 20 years, right? What you would have seen 20 years ago is, a warehouse and consuming application, right? There were no data marts. There was no need for it. But then, now you got a lot more of these data marts that are being built so that you are able to isolate data for a domain. You want to build domain-centric data marts, etc., right? So, and then you also don't get the full power of, the speed at which you want to deliver the data through data warehouse and marts. So that's where you got the lake, and you also want to be able to analyze the raw data sets. So for all of that, you need something like a lake. You can't really do all of this in a data warehouse, right? So and then, of course, the streaming side of things, a lot of times there are systems that are able to generate data really, really fast, right? POS systems. So you want to be able to consume these data sets and want to be able to combine these data sets with, something that is batch, and then want to be able to consume, right? So all of this, again, I don't have all of the data flows represented here, but when you imagine at an enterprise scale, data is flowing between, streaming, lake, data warehouse, data marts, and then from data marts again going to lake at times. So you can imagine all kinds of web of activities that are happening. Okay. So I said the data engineer, the series of activities that a data engineer does hasn't changed as much. But there is an expected, the expectation that we have about a data engineer today has changed significantly. Data engineer 10 years ago would need to be solid when it comes to databases and solid when it comes to using some of the tools to be able to, process and load the data, right? But today, especially on the cloud side, it's the platform expertise, then engineering expertise, and also the business expertise that is needed. Right? I think the previous session talked a lot about, how do you think more about the business when you start designing platforms, right? So today it's no longer, there is a separate business analyst, there is a separate data engineer, there is a separate data scientist, etc. Right? So you are expected to have some amount of business acumen and some amount of domain expertise when you are building data pipelines. That's the only way you'll actually build something that is easy for consumption. So it's not no longer about just building an architecture, building pipelines. Right? You also need to be able to figure out how you provision this data using some of the APIs, microservices, etc. You need to have some amount of app development knowledge so that you know exactly whatever data model that you are building, is that going to be sophisticated enough to power a web app, etc. Right? Then automation and agility. So how do you ensure that some of these are orchestrated well enough that you are able to reduce the overall time to deliver this data to a consuming app, right? So a lot of this is becoming part of the data engineer's routine now, right? Apart from all the other 12 different things that you saw, from identifying the data sources all the way to provisioning the data. But the more important is what is there on the right side, right? So while you do all of this on the left, ensuring that your data is ready for consumption. 10 years ago, when all of us worked with some of the MPP databases or relational databases, we didn't really focus too much on cost, right? Because you're paying fixed cost for the hardware, so you didn't really focus on how much a query is going to cost or how much a pipeline is going to cost. But today, we have the ability to granularly identify what a query or a pipeline is actually costing, right? So that means when you have that visibility, you are expected to also figure out how you actually optimize that to reduce some of that, right? So at the end, anything that you say in a platform cost standpoint is going to feed back into the building more capabilities, more features, and all of that, right? So performance is another aspect. A lot of times, we actually outsource a lot of that to database administrators in the legacy world, right? So we build something, and then somebody else actually focused more on how do we optimize and all of that. But today, data engineering is expected to focus on performance aspects as well, because at the end, performance and cost are very correlated, right? Scalability, again, a lot of pipelines that we build today is not built for one organization, right? Because there is more data that is going to come in. So how do you ensure that your pipeline is scalable and you are able to add more data without compromising on both performance and cost, right? The adaptability is, we'll talk about some of the frameworks that in the previous session also touched upon some of the low code, no code frameworks. So whatever you build as part of your frameworks, that's all to make sure that you drive some agility in the end-to-end process, right? But how do you ensure that as a company, as a larger company is able to adopt that framework, so that what you built is actually used by someone else, right? So that there is someone else is not really building altogether a new pipeline with its own structure, with its own design, architecture, and all of that, right? So now as a data engineer, you need to start thinking about, it could be a data quality framework, data ingestion framework, or data provisioning framework. How do you make sure it is, adopted by larger organization as a whole? Otherwise, again, you don't get the full benefits of building a framework. And finally, maintainability. So when we build pipelines, one of the least things that we bothered about was how do I ensure that this is maintainable, right? That was never one of the factors in any data engineer's mind as such. But somebody else actually refactored this code to make sure that code is maintainable. But today, that's part of your routine, right? So now, it's no longer about the experience factor anymore, right? So these were typically somebody high up at an architect, solution specialist, or designer focused on some of these things. But then today the expectation is that every data engineer, right from get-go is able to think through some of these parameters, because it has significant impact. Especially if you take performance and cost. If the pipeline is taking 18, 19 hours a day, using some of the best compute that is available, is going to be a big hole in someone's pocket, right? So I think the guarantee that is expected from any developer today is it optimal when it comes to performance, and is it cost effective, and can it scale without compromising on performance and cost, right? And is it maintainable in the longer term? Okay. So if you see the activities when it comes to identifying a source, taking the data all the way to consumption, nothing has changed as much. But then, in terms of what is expected from a data engineer to start thinking about, right, from designing a pipeline and then deploying a pipeline, a lot has changed, right? And then that's also driven by some of the platforms, how platforms have evolved both at the on-prem and also on the cloud. So this is a recent, again, this is completely backed by, very scientific research that our AM friends have done. So they actually did a research on data engineering market growth, what we see on the left, and what we see on the right is, again, the research actually has, a lot of other factors, but I actually took these two because these two are actually relevant for this discussion. So there is, you're growing at about 40% year on year, right? It's significant. And you look at the skills, if you see on the right, SQL Python is consistent, right? So it's like SQL is not going away anywhere. So SQL is one of the sort of the skills. And Python, of course, like I said, there is frameworks and programming that's becoming more and more common. So Python is, of course, one of the hard skills in a data engineer today, right? And then, of course, you have, a lot of other skills which are very cloud related and all of that, right? So what it tells you is, though there is a lot has changed in the platforms, the core skills that a data engineer needs today are still same, but it's just that the data engineer needs to think a lot more things other than actually just developing a pipeline and actually deploying a pipeline. Okay. Now let's talk about how T has slowly faded away. So that was my original premise. So I want to get back to this. So you've now seen what has not changed so much from developer standpoint, or otherwise a data engineer standpoint, and what has changed from platform standpoint. And with all the evolution, the T is fading away, right? So the ETL paradigm was, you spend a lot of time extracting data from different systems, you spend a lot of time transforming, and you loaded that into a data warehouse or a data mart, and that was ready for consumption. Then the transformations, you needed a separate engine to do some of these transformations, because you extracted, you needed something in between to transform and then load that to some place where that is ready for consumption. ELT is more of extracted, loaded that data, and then within the database you are able to transform. Right? When I say within the database, I'm using that loosely. So within a data platform, right? Within a platform, whatever the platform is, right? Whether it is Hadoop, whether it is Teradata, Netezza, the platforms that are still alive. Some of the platforms have long gone, but whatever remains. So there is a lot of focus still on extracting, even on cloud, extracting, loading the data, and then focus on transforming as a separate activity. Then now there is another paradigm that is becoming more and more popular, which is extract, load that information in a data lake, and then prepare the data for consumption. Right? So that prepare actually has an element of transform and a lot of data prep. Right? So it is depending on the consumers. You're actually spending a lot more time on prep or a lot less time on transform. Right? So the modern self-serve feature store is very, very focused on preparing the data sets and making sure that the features are actually maintained somewhere that are reusable and all of that. So whatever data prep programs are built is no longer just a data engineer building them. It's also a lot of data analysts who are building them. It's also data scientists who are building them. And then that's getting orchestrated in the end-to-end pipeline. It's a lot more complex in a way because obviously it's different personas who are actually building this, and when they get orchestrated, there is a lot of complexity, right? Now in all of this, why is T slowly fading away? So if you see enterprises, now systems have become a lot more, tightly coupled, right? So 10 years ago, if you see demand forecasting and your ERP, there are data sets that are uniquely different, right? So what demand forecasting solution has is only a portion of what ERP has when it comes to product information, when it comes to sales information, etc. But today, pretty much all the sales data goes into a demand forecasting solution. Or even better, ERP has demand forecasting embedded in itself. You don't really have a separate demand forecasting solution anymore, right? So that is one. The other is the ERP plus CRM are also becoming part of one system, or otherwise ERP to CRM integrations have become a lot more tighter, right? And a lot more tighter, a lot more quicker. As the transactions happen, the transactions flow down into CRM systems, etc. So PLM is another example. So product lifecycle management systems, where somebody created a product, somebody had to wait for 4 hours to see that product in the ERP system. But today, PLM, you create the product, next second you have the product in the ERP, next second you have the product in the product catalog on the ATG, right? So the integrations complexity has become a lot more simpler, and it's also become a lot more agile, a lot more quick. So you kind of get to see data in all the systems in one single instance, right? So when that happens, a lot of combining of data sets that we were doing is no longer needed, right? So because you are actually sourcing data from one system that has all of the data sets at one place. Okay. So much of the business logic, right? So that is the other thing. a lot of business logic when it comes to KPIs was also handled in DW, data mart layer in the past. But that's also going away now. Right? A lot of this complexity is handled within ERP systems, within CRM systems. So you don't really need to do a lot of this business logic outside of these systems. Right? Then data quality. So, in earlier data quality, you have to do it outside of the systems because, those controls were not in the systems. So you actually have to apply these controls elsewhere. Right? But today, there is AI-enabled quality in CRM systems. When you create a customer, the system is able to tell you by matching, millions of customers and tell you that, this is a duplicate customer. Right? So a lot of the data quality is also handled at ease in the source systems itself today, right? Again, the degree and the maturity and the scale at which an enterprise is able to do this is questionable, debatable, and all of that. But at least there is, if somebody has, somebody has put in the investment, they could actually do this really well. So, and then expectation is, faster time to insights, right? So you want to be able to bring data from source systems all the way to, whether it is Lakehouse or Fabric really, really quick. If you really have to do that, then you can't really spend time, doing transformations at different stages, right? So you're trying to minimize the number of transformations so that data is ready for consumption. And a lot of consumers today want to work with raw data sets. They don't really want to work with, harmonized data sets in a data model. That also forces, overall reduction in the time it takes to move the data. So, again, this is just a way to think about, how you would architect, data when it comes to extracting and all the way to taking it to data prep layer. So, again, all of this is impossible if you don't have right catalog, quality, recon, security, privacy, and compliance, etc. So, ensure that, part of the data foundation you have, a metric layer where your KPIs exist. You have got a data prep layer where somebody is able to prep the data, etc., for consumption. And strong data foundations, again, if you really want to focus on agility, the low-code frameworks through the life cycle, not just for ingesting data, for quality, for recon, provisioning, you need some sort of frameworks. You also need a lot more data literacy because you're not transforming the data, you're actually loading this data really quick. So that means you need some standard way to catalog this and make sure it is also available for somebody to consume, right? And then we talked about data quality and then standardized entity layer where we need good robust data models. So now let's come to the final question. Let's have 3 minutes. So cloud native zero ETL, it's almost here, right? So I mean there has been a lot of press about Amazon's announcement about Aurora able to do analysis between Redshift and the data set sitting in Aurora, right? The same way BigQuery engine is now available on all 3 public cloud platforms, right? So there are multiple enablers for this, right? So you got strong data foundation. If you architected something for zero ETL, then it is a possibility. You can actually, if you start today and start building something for zero ETL, it's a possibility, right? Fast maturing of cloud offerings, like I said, Aurora and BigQuery engine are almost there. If they mature further and there are other platforms come available and some of the data virtualization tools become real, it is a good possibility that we could get to a zero ETL world at some time, right? Catalog and lineage. Obviously, if you are not moving data, then you need stronger cataloging and stronger lineage because then someone needs to understand where the data came from and how it came from and when was this refreshed, all of that because the data is not sitting in one system. And finally, you need a lot more ownership of data, right? But there are quite a few barriers. I think the important thing is how much the barriers can actually get addressed in the near future so that this is really, really real, right? So the landscape is complex. So now obviously not everything comes into Aurora. For Amazon to really make zero ETL a reality, the expectation is that Aurora actually has all the transactional data, but which is not real. It's not going to happen overnight, right? So you have to build a lot more capabilities to be able to do that. History and changes. A lot of times for analysis, you need history data, you need to be able to combine some of these data sets. So it's not point-in-time data, right? So you also need to be able to track some of the changes. That's also critical for business, right? Change management and adoption. Again, today if you build zero ETL, you need to educate your entire organization about how to use these data sets because it's limited capabilities that you'll have, and you have to be able to work with those data sets as they are, right? And finally, how do you justify the ROI for this? If you really want to go and build a platform today for zero ETL, what are the business drivers that would actually justify the return on investment, right? So these are some of the things that all of us have to think, because the zero ETL, it's almost here, but can it really become, enterprise ready? I really don't think, we are there yet. But what will it take for zero ETL to become real? If we can address some of these barriers quickly, but none of these are actually quick, it's going to take a lot of time and effort. So if we can actually figure a way to address these barriers within the enterprise, scenario that you're in, I think, zero ETL is a possibility, and if we get to that world becomes a lot more simpler from ETL and ELT standpoint. That's all I had to say. So thank you. I ran